Hi, today I have a circular LCD board with an ESP32 and I'll do a quick review of it, and by the end of the video I hope to create something interesting with this. What I particularly liked about this board, aside from being a circular screen with an ESP32, is that it's completely circular. Aside from this tiny edge over here, the LCD and the touchscreen combo fully covers the PCB, so you can easily put this board by drilling a hole and attaching it, and then you can call it smart. Here, for example, a smart anti-rust spray. It is a little bit off-centered, but you get the idea. I was trying to find a practical application for this around the house and checking random items it might fit into. For instance, European wall outlets are almost the same diameter, with a bit of filling, and if you have a spare outlet, it could serve as a nice housing. However, I decided not to go in that direction. I didn't want to start a fight with my wife, of course. Let's check out what this board has to offer, otherwise I might come up with ideas that aren't practical. It's a little bit hard for me to keep the camera lens focused, so I'll use a microscope. The last time I tried this, the microscope screen looked nice on the video, and I'll think it'll make it easier for both for you and for me to see the details clearly. Here is the ESP32C3 microcontroller, which supports both Wi-Fi and the Bluetooth, and here is the antenna of it. The board also includes a buzzer and a vibrating motor here. And there is an encoder here, but there is no pin provided, so you'll need to find one for yourself. It has an I/O expander here, this small part, since ESP32C3 doesn't have enough pin on its own. And in addition to all that, it has a real-time clock RTC IC with its own battery. There is a socket for lithium-ion battery, and there is one USB-C connector here. This board looks like specifically designed to be used for making a watch. I am curious to see if it will fit into a standard watch case. I have a cheap watch here and I am willing to sacrifice it for this experiment. Well, it did not fit because of the small part here, but otherwise I think it is pretty nice, and if you really want it, I guess you can make it work. However, no matter how hard this watch design forces you to make a watch out of it, I don't want to make watch, at least for now, maybe in the future, with my own design. In one of my previous videos, I created a dashboard using LVGL and Squareline Studio, and both were great to work with. LVGL is an open source graphics library, while Squareline Studio is a design tool that lets you create interfaces without coding. I also realized that LVGL shines on an LCD with a high refresh rate compared to e-ink displays, and many of its coolest features are designed for touchscreens, and as a bonus, they both support Arduino. For now, I don't want to make a tutorial for LVGL and Squareline Studio, otherwise this video would be a bit too long. But let me know if you are interested in such a tutorial. I think both of them are pretty cool and definitely worth learning. Elecrow provides an LVGL 8 port for this board, showcasing some of its features, but there is also one LVGL 9 port, and even with more functionality. I have only used LVGL and the Squareline Studio once, but it was surprisingly easy and fun to work with. I even received a few comments suggesting I create a tutorial on it, and yes, I read every comments you make, even if I sometimes don't have time to reply to them. By the way, the colors looks nice in my opinion. It's an IPS screen. Let's check the viewing angle. Yeah, it is visible even from wide angles, which is also nice. I have found this stainless steel vacuum flask in the home, and it seems like it has a similar diameter as this display, and I think it would be a nice application to make a smart bottle out of it. Maybe I can show the temperature of the liquid inside and program it to remind me to drink water every hour or so. The cap is also stainless steel here, but this part is plastic and it feels like it's glued here. But I believe they did not use glue to hold the stainless steel here, and only the plastic is providing the adhesion. What I will do is I'll put the cap here and slowly heat up using a butane lighter. If there is no glue, it should be easy to remove the stainless steel part from the cap. Okay, this worked out pretty well and I was able to remove the stainless steel part from the plastic. I also drilled a hole on top of the plastic. I plan to put a battery inside and I can design another cap to put on top of this so it will look tidy. Well, I ported LVGL 9 on this, and this is really a simple sketch by the way. Just the value here follows the arc, however it's terribly slow, and the reason is there is not enough RAM in ESP32C3. So either you can try to optimize things and etc. using LVGL 9, or you can go back to LVGL 8. So I don't want to spend time on optimizing anything. I am gonna just... It is really not usable at all. I converted the same code to LVGL8 and the reason is the RAM overflows, and I think it is better because as you can see it's pretty responsive compared to the other one. Of course in the code what I think would be nice to this arc to be not settable with my finger. Instead it will show the temperature and the arc will move according to the temperature. That's my plan currently. I cut the stainless steel from the top to see how this thing feel like in the real life, and I have to admit stainless steel looks really nice and I wish I had a way to manufacture a stainless steel cap like this. Unfortunately I don't have any CNC machine or anything, so instead I will design something 3D printable so it will look more decent than this. I plan to measure the temperature using a thermistor. This is 100K thermistor, which is placed almost all 3D printers anyway, and put it inside and get the temperature reading of this side of the plastic. It won't be an accurate temperature reading because the temperature here and here will be quite different. However, I think the liquid inside will stay here for hours and probably the delta temperature will be too small. So I think it should work fine. And after everything is finished, I plan to put a battery plus this thing here and seal this up, and probably using a silicone or something. It's not really that good, I know, however it should work just fine. Then I will just seal this thing up and place it here. Well, I guess it would look nice. Let's see. So right now I faced a small challenge, and this is because there is no extra pins left for you to solder the thermistor on this thing, and I have to sacrifice something. I can either sacrifice the encoder here or the button. Well, considering the footprint of the encoder is so small, I think I'm gonna go with the button one. It would have been nice if they had an extra place where we can put our solders in, but well, this will do for now. I did the soldering of the thermistor and it works fine for now. You might be wondering how I soldered this. Well, instead of using a separate pin because you don't have any, I used other connections. So I am getting 3 volts from here, from this connection, and I installed 100K resistor here, and that is connected to thermistor, and other one is going to the button, and that one is connected to pin 1. And also here, that's the ground pin, and that one is also going to the thermistor. That's basically how you make a thermistor circuitry. Also, there was a sneaky resistor here It's not visible here. I will show it in a circuit diagram because without removing it, you will get all weird readings out of it. And before I do the final installation, I will remove the LED from here to save some energy out of it, so the battery can last a bit longer. The 3D printing is complete, and I desoldered the LED and soldered a lithium-ion battery to the board. Currently, I am charging the battery, and I decided not to use any glue because it didn't leak tight, and I plan to put it in dishwasher for cleaning, so I wanted a removable solution. Because of this, I designed the 3D print to be a tight fit. This bottle is fairly generic, but if you can't find one with the same diameter here, you might need to design your own cap. This is the screen design that I came up with. A quick note, once you start working with LVGL and Squareline Studio, you might find yourself spending a lot of time on the screen design. For this project, I avoided using graphics and relied solely on LVGL styling options because graphics consume a lot of RAM and memory, so I opted for a lightweight approach. In the middle of the display, it is the temperature measured by the thermostat. There are two arcs on the screen. The outer arc, this green one, moves dynamically as temperature changes, and there is an inner arc here. The inner arc represents the remaining screen backlight time. It's slightly transparent, so it might be not very visible on the video here. Additionally, the device has Bluetooth functionality. You can access it using NRF Connect app. While I considered developing a dedicated app for this, NRF Connect already fulfills the same purpose. And when scanning, let it give a few seconds. Look for the one named Maker's Fun Duct and click Connect to access the device. The device name is Smart Flask. In the health thermometer service, if you click this button, you can read the latest temperature as a temperature measurement. It is the same temperature which is shown here. And also here I put an alert notification service and I added a time to update the time control point, which means how often this device is going to trigger and remind you that you need to drink water or any liquid that you put in your bottle. Currently, the water drinking alert is set to 16 minutes. You can check the current time by clicking this button here or update via the Bluetooth by sending a text command. For example, I will set it 1 minute for the demonstration. Right now, it will trigger every minute. Further down, you can see the alert status. This device accepts any text and starts as an alert, which can be useful for locating it if misplaced. Let me show it to you. I will just send random data and it will alert you. Touching the screen anytime displays the temperature as shown earlier. Unfortunately, I couldn't enable the deep sleep mode in the code. Despite my efforts, I couldn't find the datasheet explaining how to enable the touch interrupt pin. The touch is connected to ESP32 and enabling it could save significant battery time, but for now I simply turn off the LCD screen to conserve some energy. I poured some hot water to test its functionality and it displays the temperature of 84.5 degrees, indicating that it works as expected. Now I can check the temperature before drinking and avoid burning my mouth like I did before. While working on this project, I thought about creating a smart mug. Imagine a mug when placed on a wireless charger can heat the water, brew tea, and maintain your favorite temperature. Do you know any heating components, preferably in a film form, that could fit inside a vacuum flask or a cup? Such a smart cup would be both useful and cool. I think this project is concluded, so stay hydrated, my friends. See you next time.